This video will cover experiment number 8, simple and fractional distillation. We will go over the procedure and the data collection for each. We're going to start with the simple distillation. These are all of the pieces of glassware and equipment that are necessary. A thermometer that goes above the maximum boiling temperature of your solution. A thermometer adapter. A connecting adapter, also called a Y adapter. A round bottom flask with a small stir bar or boiling chips. A water condenser, and something to catch the distillate. We are using a graduated cylinder so we can keep track of the volume collected. Each of the ground glass joints will be secured with an O-ring and a screw cap. This video shows the importance of using an O-ring and a screw cap. Without anything, they can be easily separated. If we secure them with just the screw cap, they can still be easily separated. So in order to secure them, we place the cap and the O-ring onto one of the pieces of glassware. And then when we screw the cap on, the two pieces of glassware are sealed and connected to each other. When we set up the glassware, we also want to make sure that our thermometer bulb is in the correct location. We want our thermometer bulb below the neck of our connecting adapter, but above the neck of our round bottom flask. And our water hoses are attached to the water faucet and the drain, and it's important that they're connected in a way that we fight gravity. Our water condenser is pointed downward, and so the hose that goes from the water faucet should always be connected to the lower water opening, and then the upper water opening should always have a hose going towards the drain. And this may need to be secured with tape depending on how long the hose is. Here is the complete setup for the simple distillation. In addition to the pieces mentioned, there is also now 8 milliliters of solution in our round bottom flask. It has been placed onto an aluminum heating block, which has then been put on a hot plate. In order to start the distillation, the water is turned on very slowly in order to fill up the water condenser and keep it cool. The hot plate and the stirrer are turned on to heat and stir our solution. As our solution heats up, the vapor rises. As it hits our cold water condenser, it recondenses into a liquid, drips into our graduated cylinder, and is collected. The goal is to have our solution boiling and our distillate being collected at 1 drop for every 5 seconds. It may be necessary to turn down the heat after the reaction gets going. For the fractional distillation setup, most of the pieces are the same: thermometer and adapter, connecting adapter, water condenser, graduated cylinder, round bottom flask with a stir bar. The additional piece is right here in the center. It is called a fractionating column. Here is an enlarged picture on the side. It has small glass nodules that stick into the column that provide more surface area for our solution to condense on as it is being distilled. Again, the setup is very similar to our simple distillation apparatus. We have our round bottom flask with its solution sitting on an aluminum block and a hot plate. The water goes into that lower opening and out the upper opening, and our hoses are connected to the water faucet and then down into the drain, and our solution is collected in a graduated cylinder. In order to start the procedure, the water is turned on, the heat and the stir plate are also turned on. There are 2 additional steps that are needed. Because our fractionating column makes our setup much taller, the graduated cylinder is placed on a lab jack just to place it at the right height so the distillate can drip into that graduated cylinder. And aluminum foil is added around that fractionating column to help insulate it. As the distillation continues, the data is collected. For each of the simple and the fractional distillations, for every 0.5 milliliters of distillate collected in the graduated cylinder, the temperature on the thermometer was recorded. In addition to temperature and volume data, after 1 milliliter of distillate was collected, the next 4 drops were collected into a GC vial so that it could be analyzed with a gas chromatograph. This was repeated at the 5 milliliter mark, and then it was repeated again for the fractional distillation at the 1 and the 5 milliliter mark. And this is the extent of the data for our distillation apparatus.